Hello. Hello students, welcome to the world of chemistry. This is Dr. Vikram Panchal and I was dealing with spectroscopy. This is lecture number 11. Well, in this lecture I will explain you the application of Lambert's-Beer's law. A is equal to absorbance and how this A is connected to concentration, which is equal to epsilon BC. This is in fact part of previous lecture which I missed. I could not complete it. Therefore, I am repeating this once again. Absorbance is equal to epsilon into thickness of the path length and into concentration. Now, when we plot a graph of absorbance versus concentration according to y is equal to mx plus c, here plus 0, that means there is no interception. So that means if A versus C is plotted, the line will pass through origin with 0 interception. So there will be no interception in this case. Okay, and here m is equal to epsilon b, and that is nothing but slope. So here, if you write x, y, z over here, then slope is equal to xy upon yz, and slope is equal to epsilon b. If b is constant, say b is equal to 1 centimeter, then slope will be equals to epsilon. So this way we can get epsilon value from this graph. Okay. So here this graph shows that as absorbance increases, concentration also increases or vice versa. So absorbance is directly proportional to concentration. So this is a graph which gives us this information. Now we will see relation between transmittance and absorbance. Relation between transmittance and absorbance. So you know that A is equal to log I0 upon I, and T is equal to I upon I0. So you can see these two are opposite. So here if we relate these two, then we write A is equal to log 1 upon T, or we can write A is equal to minus log T. If percentage transmittance is given, then percentage transmittance is equal to I upon I0 into 100. Okay. From this we can find out relation between A and percentage transmittance also. So if we write percentage transmittance is equal to I upon I0 into 100, we take log on both the sides. So log of percentage transmittance is equal to log of I upon I0 plus log of 100. You know log 100 is equal to 2. So log percentage transmittance is equal to, this is opposite of log A, absorbance, because absorbance is equal to log I0 upon I, and therefore we can write minus A for this plus 2, and therefore A is equal to 2 minus log percentage transmittance. So this way we can find out absorbance if you know percentage transmittance, or you can find out percentage transmittance if you know absorbance. Okay. Now in ultraviolet visible spectroscopy, the instrument used is known as UV spectrophotometer, UV visible spectrophotometer. And it gives us graph which is different. So the graph obtained from this instrument is like this. Here on y-axis we take absorbance, but on x-axis we take wavelength, lambda. And the range of instrument is 200 nanometer to 800 nanometer. So we get graph between these two only. And the mode of graph is like this. It can be like this. So here, at this point, the height of the graph or peak is maximum. This is a peak which we obtain in ultraviolet UV visible spectrophotometer, and this is called lambda maxima, and the value of absorbance at this peak is called epsilon maxima. Okay, so this way we get epsilon maximum, it means highest intensity at this wavelength. Okay, now in this is called UV spectra. This is known as UV spectra or UV visible spectra. Basically, in this spectra, we observe not only electronic excitation, electronic excitations, lines due to electronic excitation, but also due to vibrations and rotations. So it is a mixture of several lines, not only one lines, but several lines, because there are so many lines between two electronic levels, like sigma and sigma star, or pi and pi star. Between them also there are so many vibrational levels, so many rotational levels within vibrational levels. That means there are so many lines. It's a bunch of lines, and this bunch of lines produce peak. So we get a huge peak because of this reason. Okay. Now we have to interpret this peak also. What is the meaning of this graph? Let us see this one. So here this graph shows that because of presence of certain types of structure, particularly unsaturation, that means there should be pi bond, or chemical bonds, mostly pi bonds. The molecule absorbs a light of definite wavelength and maximum intensity, which is called lambda maxima, and maximum intensity, which is called epsilon maxima. for their electronic transition. That means electron only travel to excited state because it absorbs this light of lambda maxima. Okay, so that is very, very important, and thus we obtain important informations from this graph as follows. The first information obtained is how many number of pi bonds present in the molecule. That information obtained from this graph. Second, the position of pi bonds. See, on the basis of this, we come to know the system present in a given compound. The system means the type of bonds present in a given compound. Now, I'll give you some explanations or examples of certain systems like diene, trine, enone, and benzoyl system. For example, when there are at least two conjugated double bonds, conjugated means alternate double bonds. We call it conjugated diene system. An extended diene system is also possible, like if more than 4 carbons are present in series, and if more than 2 alternate pi bonds are present, then we call it extended diene system. Here it is called trine, but it is in fact extended diene system. Then we can have enone system. If carbonyl group is present along with some atom Z, then C single bond C, then double bond C, etc. Then you will see that C double bond O and C double bond C are in alternate positions, and they are called that is enone systems. So this is enone system, and we can predict what kind of enone system is present from the graph. Then we have benzoyl system, in which there will be aromatic ring along with C double bond O with Z. Okay, here in both the cases, Z can be H, OH, then OR, NH2, R, etc. Okay, these are all different functional groups, but we call it benzoyl system, and that also can be determined from the graph. So graph gives us this much information about the given organic compound. So that is why this graph is very important for any organic chemist. Thank you so much.